We are living with an invisible snowfall of plastic. Every time we twist a bottle cap, microwave leftovers in a plastic tub, or simply breathe in city air, we shed and inhale specks so tiny that they make dust motes look enormous. These specks, nanoplastics, are smaller than a single red blood cell and can glide through the gut wall, catch a ride in the bloodstream, and settle deep inside our organs. While their larger cousins, microplastics, already worry scientists, nanoplastics may be the stealthier, more dangerous threat, quietly shaving years off the healthy life we hope to enjoy. They begin as everyday objects: water bottles, grocery bags, polyester shirts, car tires. Sunlight, heat and friction grind them into microscopic shards. A child's forgotten beach bucket can seed millions of fragments into the sand in a single summer. From soil and sea, these particles drift into our food chain. Laboratory tests have counted tens of thousands of nanoplastic pieces in 1 liter of bottled water. A takeaway coffee in a plastic-lined cup feels harmless, yet steam strips particles that mingle with the espresso. Even boiling pasta in a scratched, non-stick pot can pepper your dinner with plastic dust. Once swallowed or inhaled, nanoplastics meet few barriers. The intestinal lining, designed to admit nutrients and repel invaders, cannot reliably detect something so small. Some slip through tight junctions, others ride immune cells patrolling the gut wall. In blood they drift to the liver, kidneys and brain, or lodge inside fatty plaques that clog arteries. Surgeons analyzing carotid blockages recently found that stroke patients carried far more microscopic plastic debris than people without strokes, a flashing red light for anyone who values long, disease-free years. Picture gritty sand scraping a delicate machine. These tiny plastic bits are hard to break down, and their rough, sticky surfaces latch onto harmful chemicals and carry them deep into our tissues. When a cell swallows one, the particle can scrape membranes, jam protein machines and, worst of all, puncture mitochondria, the cell's power plants. Damaged mitochondria leak reactive oxygen species, hot molecular sparks that chew DNA, oxidize fats and flip stress switches driving cells toward premature aging. The immune system rushes in, releasing inflammatory molecules meant to heal. But the particles linger, the alarm never shuts off. Inflammation becomes chronic, the slow burn known as inflammaging. Over months and years, that smolder stiffens arteries, clouds memory and weakens muscle. Some cells, battered beyond repair, enter zombie-like aging. They stop dividing yet refuse to die, leaking toxins that push neighbors down the same path. Aging cells pile up in wrinkled skin, aching joints and failing organs, hallmarks of aging arriving too soon. Animal studies echo the danger. Nematode worms, beloved by longevity labs because they reveal lifespan shifts within weeks, lose up to 1/3 of their expected life when raised on nanoplastic-laced food and wriggle more sluggishly. Mice sipping nanoparticle-spiked water for months grow hearts that mimic those of far older animals, stiff muscle fibers, misfiring calcium pumps, soaring aging markers. Scientists traced the carnage to mitochondrial DNA leaking into the cell's interior, lighting up an inflammatory alarm called Sting, a pathway common in human age-related diseases. Fish, fruit flies and human cell cultures repeat the pattern: more oxidative stress, more inflammation, earlier decline. Human evidence, though still young, walks the same road. Beyond artery plaque discoveries, researchers have detected nanoplastics in blood, lung tissue, placentas and even the brain. These dots align with processes longevity experts struggle to calm: mitochondrial dysfunction, DNA damage and relentless inflammation. Aging science lists 9 interconnected hallmarks. Nanoplastic exposure pokes several at once, an alarming multitasker capable of accelerating multiple biological clocks simultaneously. How much exposure is too much? No one yet knows the threshold. The menace is cumulative. Plastics already lurking in landfills, rivers and oceans will weather into ever smaller particles for decades, even if production halted tomorrow. Personal choices therefore matter, especially for anyone determined to stretch the healthy slice of life. Start with water. Install a filter certified to capture submicron particles, reverse osmosis membranes or high-grade activated carbon blocks, to slash a major intake route. Next, banish hot plastic from the kitchen. Tip: take away soup into ceramic bowls, store leftovers in glass or steel, trade the plastic kettle for metal. Heat makes plastic give off particles more quickly. Choose loose produce over shrink-wrapped versions and carry a cloth bag. At home, treat indoor air as another battleground, run a HEPA purifier where you spend most time, and use a vacuum fitted with a HEPA bag to snare fibers shed by carpets and clothes. Diet offers a second shield. Plates bursting with berries, leafy greens, herbs and omega-3 rich fish flood the body with polyphenols that neutralize reactive oxygen species and soothe inflammation. Exercise supplies its own anti-aging medicine, boosting circulation and mitochondrial resilience, an internal cleanup crew that can mop up some plastic-induced stress. These habits cannot erase exposure, yet they fortify repair systems while society tackles bigger fixes. And bigger fixes are essential. Individual action only goes so far when nanoplastics swirl through entire ecosystems. Stemming the tide means banning needless single-use plastics, redesigning packaging for safe reuse, investing in truly circular materials, and cleaning up debris already loose in the environment. Every politician outlawing flimsy shopping bags, every company ditching plastic microbeads, every engineer inventing a biodegradable alternative chips away at a problem measured in trillions of particles. As we map the full story of nanoplastics and aging, new questions crowd in. Which plastic chemistries, from PET bottles to nylon fibers, prove most toxic? Do nanoplastics team up with other modern stressors such as high blood sugar or urban smog? Might certain fibers, probiotic strains or future drugs, sweep lodged particles from our tissues? Scientists are building global biomonitoring networks and drafting plastic exposure clocks, akin to biological age tests, to reveal how fast invisible polymers nibble at our years. Until those answers arrive, one principle stands firm: what helps the planet often helps personal longevity. Clearing plastic from oceans not only saves wildlife but also reduces the microscopic rain drifting onto dinner plates. A stainless steel lunchbox cuts landfill waste and, by extension, the number of particles migrating into human arteries. In an era brimming with gene-editing dreams and biometric wearables, the humble act of saying no thanks to a plastic straw, and insisting on smarter materials, may be one of the simplest, most immediate ways to protect the span and sparkle of our lives. We cannot see, taste or smell nanoplastics, yet they ride modern currents from factory to kitchen to bloodstream. Worms, mice and human arteries all warn us that these minuscule hitchhikers scrape the gears that keep us young. Fortunately, many exposure pathways flow through habits we can change today and policies we can endorse tomorrow. By framing nanoplastic reduction as both an environmental duty and a personal anti-aging strategy, we can start sweeping those invisible fragments off our plates, and perhaps add a few bright, healthy candles to future birthday cakes. If you find this video helpful, please like, subscribe, and hit the bell for updates. Share it with someone who might benefit, and drop a comment. I'd love to hear from you. Thanks for supporting the channel and being part of the community.